Hi, my name is Vaibhav Parchari and today we have experiment 6, which is our development and testing of a voltage regulator using Zener diode. So this experiment is divided into two parts. In the part 1, I am going to conduct this experiment through a software called LT Spice. In this software, I am going to run the simulation of this circuit. And in the part 2, I am going to conduct the same experiment through our breadboard. So this is my ID. Okay, so let's just begin. Okay, so in part 1, which is a simulation study, I downloaded LT Spice software. Now set the parameters. The series resistance is set to 250 ohms and the Zener diode breakdown voltage is set to 3.6 volts. And this load resistance is varied to 100 ohms to 10 kilo ohms. Now this is our output waveform, which is in blue lines. To simulate the voltage regulation, the load resistance is varied from 100 ohms to 10 kilo ohms. For each load resistance, the output voltage is calculated in check if it falls within the regulated voltage range of 3.6 volts plus minus 0.2 volts. Now I'm going to vary this 100 ohm resistor to 1000 ohms and let's just see the output. Okay, so now the output voltage comes. The simulations shows here that the input voltage waveforms included the 4.3 volt DC source and a zero point 0.5 triangular wave. The output voltage remains regulated within 3.6 volts plus minus 0.2 volts. For the load resistance, now I change this RS to 500 ohms and let us see the expected outcomes. After change it to 500 ohms, the sensitivity to the series resistance, which is our RS, increasing from 250 ohms to 500 ohms significantly narrows the range of load resistance over which effective voltage regulation occurs. The demonstration there implements the critical load plays in balancing current flow through the Zener diode in the load. Earlier, RS improves regulations against input voltage variations, but reduces the circuit's ability to handle a wide range of load. Hence, I'm changing the load resistance from 100 to 10K. The output voltage slightly changes. Okay, so now after connection of multiple Zener diodes, I'm going to connect two identical Zener diodes in series doubles the regulated voltage, which is 3.6 to 7.2 volt. However, this configuration also narrows the effective regulation range for load resistance. The trade-off between higher regulated voltage and a reduced flexibility in load handling is important to consider its design choice. However, the regulation performance doesn't scale linearly with the change in component value. This non-linearity emphasizes the need for careful simulation and testing when designing voltage regulation specifically. So in part 2, which is our experimental study, I set up the circuit according to the figure that this is our 220 ohm resistor. In series connected to a Zener diode, and it is a pot. Connection goes to second pin, and our third pin is grounded. The pot here works as a load resistance. I'm gonna vary this load resistance and see the output through our pixel pulse. At the end, our output tends to 0. Okay, so now I'm gonna add another Zener diode in series with Zener diode, which has a breakdown region 3.6. So now I'm gonna add another Zener diode in series of this Zener. And the breakdown region is 3.6 volt for the first Zener and the second for the 3.6. So our total 7.2. After 7.2, it acts. The voltage is going to vary. Okay. So now our output is. I'm gonna vary this. Increase the load resistance. Okay. This is our before. Easily cross the output voltage. Again, so I'm gonna vary this to 5 volts. Okay, so after all, this is our week 6 experiment. Thank you.